Hello everyone, hope you are doing well. Today we are solving our next problem, which is finding the kth maximum and minimum element of an array. Let's move to our problem statement. In this problem we are given an array and an integer k, where k is smaller than the size of the array. Your task is to find the kth smallest element in the array. Suppose the array is this and k is 3, so the third smallest element is 7. Let's move to our code editor to understand this problem more clearly. Suppose we are given an array like this: 1, 3, 2, 5, 8, 0 and 6, and k is 4. K is 4. So the first smallest element is 0, the second smallest element in this array is 1, the third smallest element in this array is 2, and the fourth smallest element in this array is 3. So we have to return this 3. So the first approach that we can think it of is, if we sort the array will become like this: 1, 0, 1, 2, 3, 5, 6 and 8. The indexing is 0, 1, 2, 3, 4, 5, 6. So the first smallest element is at 0th index, second smallest element is at 1th index, third smallest element is at 2nd index, and the fourth smallest element is at 3rd index. So kth smallest element, it is at k minus 1th index. So what will be the step? Step 1 is what? Sort the array, sort array, and then return ARR of k minus 1. Let's move to the implementation part of it. So sort ARR dot begin, ARR dot end, simply return ARR of k minus 1. Let's compile it. Yes, this passes the test cases. Let's submit it. It gives the correct output. The time complexity of this approach is order of n log n, and space complexity is order of 1. Let's move to our next approach. So in this, suppose we are given an array like this: 1, 7, 5, 3, 2, 8, and k is what? 4. Here we take the use of priority queue. Here we create the max heap. So in max heap, we store the element. First we store 1, because the size of max heap is lesser than the value of k. So until the size of max heap is lesser than k, then we store the value into max heap. If the size is equals to k, then we check if the topmost element is greater than the upcoming element. Then we pop out the topmost element and insert the upcoming elements. Let's see how this happens. Now 7 is coming because the k is because the size of priority queue is lesser than k, so we insert 7. Now again 5 is come, so we remove 7 first, insert 5 here, and then 7 comes. Now 3 comes over here before because the size is lesser than, so we remove it, take it to correct place. I hope you know priority queue very well. So again 5 come. If you don't know, if you wish, I will create video on it. So now the 2 is coming because the size of a priority queue is equals to k. So we check the topmost element. Are you greater than k? Are you greater than the upcoming element? Yes. So we popped it out. So we remove it and insert our 2. So 2 comes here, then 3 comes here, then 5 comes here. Now again 8 is coming. Sorry, 8 is coming. So the topmost element is already smaller than the upcoming element. So we do nothing. So the topmost element will be our the kth smallest element. So we simply return the topmost element of the priority queue, which is 5. Now move to the implementation part of it, and then we dry run the code. Let's first clear the code editor. First create the priority queue underscore queue of int pq. Take a loop for int I is what 0, I should less than arr dot size, I should be incremented. If pq dot size are lesser than k, so simply we insert arr of 5. Otherwise we check if pq dot top are you greater than upcoming element, so we pop the topmost element and we push the arrow 5, and then we simply return the topmost element of priority queue. Now compile it. It passes the test cases. Let's submit it up. Yes, it's executed perfectly. Let's take the screenshot of it and move it to the our whiteboard. So paste it over here, make some space, so adjust it. So hope this is visible to you clearly. Suppose the array is like this. Wait a minute. Suppose the array is given like this. An element will be 1, 5, 3, 2, 7, 4. Indexing will be our 0, 1, 2, 3, 4, 5, and you are given k as 3. So by using priority queue we create our queue. Suppose the queue is looking like this. This is our pq. Initialize our pointer to this index. So is pq dot size 0, which is lesser than k. So we directly push 1 into our priority queue. Now move the pointer one step ahead. Now again the priority queue size is lesser than k, so we push 5 in our priority queue. Now increase the pointer by 1. Now again, the size of priority queue is lesser than the value of k. So we push 3 in our priority queue. So instead of 5, wait a minute. So 5 comes top and 3 comes over here. So again, we move our pointer one step ahead. Now the size of our priority queue, the size of our priority queue is greater equals to the value of k. So this condition fails. So we move to our else part. Now we check pq.top, which is 5. Are you greater than error of I? Condition true. So we remove the topmost element. We remove the topmost element and insert 2. So write it its correct position. So 2 comes here and 3 comes here. Now increase the pointer by 1. Now check for 7 because the priority queue size is equals to k. Now we check pq.top. Are you greater than error of I? So pq.top is what? 3. Are you greater than 7? Condition false. Do nothing. Move the pointer one step forward. So again 4 is coming because the size of priority queue is not less than k. So we move to the else part. Now we check priority queue.top. Are you greater than 4? Condition false. Do nothing. So increase the pointer by 1. So we reach the end of the loop. Now we do nothing. Simply return the top value of PQ, which is 3. So that's our answer. The time complexity of this approach is order of n log k. Because n is for this loop and k is for the priority queue. Because you know the insertion operation takes order of log n time complexity. So here in this case we have at max k element in our priority queue. So order of log k will be the time complexity and order of log k will be the space complexity, because at a time there may be a k at most k element in our priority queue. Let's move to our third approach, which is the inbuilt method in our C++. In this we simply return nth underscore element arr.begin plus k comma arr.end. By doing this, it plays the kth element to its correct order. Simply we return arr of k minus 1. Let's compile it. Yes, this passes the test cases. Let's submit it. The time complexity of this approach is order of n. But there is an issue in this. Oh, sorry, in place of k minus 1 is come here because indexing start with 0 and the k element comes. Let's submit it up. If you find my video helpful, then don't forget to like, share and subscribe. Thank you.